Okay, this is a video on synthetic division, which is another technique for dividing polynomials. I think it's more efficient. However, it's not a mathematical process. It's kind of a shortcut. If you become proficient in using the shortcut, you can feel free to use synthetic division for all your polynomial dividing needs, unless on a test I ask you to use polynomial division explicitly. I would never ask you to use synthetic division explicitly, though. So learning this process is kind of an aid and an extra toolkit or extra tool for you when dividing polynomials. So this is a video on how to do it. So let's say we wanted to divide 3x cubed minus 5x squared minus 7x minus 1 by x minus 3. In order to do synthetic division, we don't use the x's. We just use the coefficients, and we don't use the factor x minus 3. We only use what would be the root of x minus 3. So in this case, it would be 3. It's what would we put in here to make that equal 0. So in this case, 3. So here's how we set it up. We'll call this step 1. We write our root, k, right here. And we write the coefficients of our polynomial that we're dividing by along the top. So the coefficient on the x cubed term is 3. The coefficient on the x squared term is minus 5. Coefficient on the x term is minus 7. And the coefficient on the constant, or just the constant, is minus 1. Just like in polynomial division, if we were missing one of those terms, we'd have to use a placeholder, and our placeholder would be 0. And also, if it was out of order, we'd have to rewrite it in the proper order of descending power. And in this case, we have our cubed, then our squared, then our x, then our constant. So we are in order. Now, how do we do it? Well, we start always by bringing down the first coefficient, 3. That's our first step. Second step, I'm going to rewrite it here, 3, minus 5, minus 7, minus 1. We brought down the 3, so we're here. What we do now is we take our root, k, 3, and we multiply it by whatever's on the bottom here, and we write our answer right here. So 3 times 3 is 9. And then we add down the column. Negative 5 plus 9 is 4. And then we repeat the process. So I'm going to rewrite up here. We've got 3, minus 5, minus 7, minus 1. We got 3 and 4 on the bottom. So we're going to do 3 times 4, which gives us 12. And then we're going to add down the column. Negative 7 plus 12 is 5. That's our step 3. And step 4, we're going to repeat the process one more time. And we've got 3, 4, 5. So we're going to take our 3, multiply it by 5. We get 15. And then we're going to add down the column. Minus 1 plus 15 is 14. What do these numbers on the bottom mean? Well, these are the coefficients on your polynomial quotient. Your polynomial divisor was x minus 3 from the very beginning. Your quotient will always be 1 degree less than what your original dividend was. This is a degree 3 polynomial. When we divide a degree 3 by a degree 1, we get a degree 2. So it's going to be 3 is the coefficient on our x squared term, 4 is the coefficient on our x term, and 5 is our constant term. That leaves us with this 14. That 14, that's the remainder. If you're not sure how to write it in order, work from the end. The last term is always the remainder, so that makes that the constant, that the x term, that the x squared term. If there's more terms, then it'd be x cubed, then x4, but there's only the 4 terms in this case. So we've got remainder, constant, x squared term. And that whole thing equals our dividend of 3x cubed minus 5x squared minus 7x minus 1. Now, at the beginning I said it was more efficient. This does not look more efficient. This layout is only to show you the steps. To actually lay out the question or format the synthetic division, we do it all on one image. So I'm going to do that one below. We're going to divide 13x minus 2x cubed plus x to the exponent 4 minus 6 by x plus 2, and we're going to do it to determine whether x plus 2 is a factor of this polynomial. And we'll learn next lesson that it's a factor if it divides with no remainder. So at this point, if we get a remainder of 0, we know it's a factor, because when we write our division statement, we don't have that plus part, and on the left here, we just have factored form of an original polynomial. And we'll talk more about that in the next lesson. But for now, remainder of 0 means factor. So let's try our polynomial division. We know this needs to be in order, and we need to insert placeholders if we're missing terms. Our biggest power is x4, so we'll start with x to the exponent 4. We have an x cubed term, so it's negative 2x cubed. We're missing an x squared, so 0x squared. We have an x term, 13x. And we have a constant, negative 6. And we want to determine if x plus 2 is a factor. So we're going to divide this polynomial by x plus 2. If we have x plus 2, that means that the k, or our root, is negative 2. So when we write our synthetic division, big L, the number that goes to the left here, negative 2. The numbers that go along the top are the coefficients on our terms. 1 is in front of x to the exponent 4, negative 2 is in front of the cubed, 0 is in front of the squared, 13 is in front of the x, and negative 6 is our constant term. So here we go. Let's do synthetic division all in one go. Bring down the 1. Negative 2 times 1 is negative 2. Add down the column. Negative 2 plus negative 2 is negative 4. Multiply negative 2 by negative 4, get 8. Add down the column. 0 plus 8 is 8. Multiply negative 2 times 8, negative 16. Add down the column. We get negative 3. Multiply negative 2 by negative 3, we get 6. Add down the column, we get 0. In the above example, I said the last number, 0, is the remainder. So we have 0 remainder, which means that x plus 2 is a factor. Let's write our division statement. Our divisor, x plus 2, times our quotient, which is represented by these coefficients. So if this is the remainder, that's the constant, that's the x term, that's the x squared term, oops, that's the x cubed term. So we've got 1x cubed minus 4x squared plus 8x minus 3. And that whole thing equals our original polynomial, x4 minus 2x cubed plus 13x minus 6. So we have partial factoring here. We pulled out a factor, and we have our leftover. Okay, that's an example of dividing using synthetic division. Thanks for watching. There is a part 2 on how to divide when your factor isn't simply x plus or minus a number. And if you want to explore that, you can watch that video. If you don't like synthetic division, don't worry about it. You don't have to use it. If you are happy with just dividing using synthetic division, when you have x plus or minus a number, you can stop right here. All optional. Okay, thanks for watching, and I'll see you next time.